Today we're going to be doing a power outage simulation test where we're going to test my generator and all of the other backup systems I have in place. We're going to be doing a nighttime generator test of my homemade backup generator that I have created. I won't go too in depth because I have many videos on the system, but long story short, I constructed this generator building with automatic heating and ventilation with a automatic opening damper, and on the other side I have an exhaust fan with louvers on it to keep the building dry and warm. I have a gasoline generator as my backup power source because we don't have natural gas or propane, and the only way to construct my own at a reasonable cost was to buy a gasoline powered manual generator, and then I installed a module on it and a automatic transfer switch to make it fully automatic. I have videos on all of that. This is an inverter generator, so I have always a very clean power source, so it's okay for electronics and it doesn't make your lighting have any sort of flicker like generators with a higher level of total harmonic distortion will. You can see it is nighttime here. It is raining. We are supposed to get a rain windstorm later on tonight and tomorrow, so the generator may be needed. We'll see. Inside the generator building here is our generator, our automatic damper, our heat lamp. We have a block heater on the generator, and we have our battery charger and all of what controls our ventilation system. Turn on that emergency light for some better light. We are monitored by the fire alarm system for high and low temperature, as well as smoke and heat detection should things go really wrong in this building. But like I said, I've got videos on all of this, so I don't want to bore you with all of this stuff here. Going inside our main garage here, this is our utility corner where we have the fire alarm system, sprinkler system, electrical distribution, and where every service comes in. Inside here is our automatic transfer switch, which if you hit it hard enough, you can pop it open, as I don't latch it. And here is our automatic transfer switch. I do have various time delayed relays and different time delays that are built into the program of the generator controller, so I will give a brief sequence of events. Once utility power goes out, the generator controller will wait 10 seconds before starting the generator. Once the generator is started, the time delay relay in the transfer switch will wait an additional around 3 or 4 seconds to make sure that power is stable before transferring the building's load. And then on the other side of things, once utility power is restored, the transfer switch will wait 30 seconds before transferring back to generator power. And then the generator, from when utility power is restored, will wait 1.5 minutes before shutting down to give it a bit of a cool down period. And the 30 seconds before transferring is just to make sure power is good and stable before transferring back to that utility power. Everything you see here is something I have created by myself and homemade. This is all something that has been made out of different parts, like taking a standard generator, just a portable generator, putting it in a building with automatic heating and cooling, pairing it with a automatic transfer switch, which I have made my own changes to its sequence of events and timing with the time delayed relays. I'm going to set up a few different camera angles to be able to capture the whole operation of all of the equipment. I'm going to have this camera that's currently filming me outside, which will watch all the power go out, generator start, and all that. And then this one here can watch the transfer switch operate. And then over here, at this end, this iPad that is over here can watch everything from over here. With all of that said, let's go ahead and give this a test by actually shutting off power to this whole building from inside the house and creating a full-on power outage, just like what would happen if utility power was all of a sudden lost. And there we go. We are now on generator power. You can see the damper is now beginning to open and our exhaust fan is running. The generator is now running this building. The generator has 8,000 starting watts. So basically it's rated at 8,000 watts for up to 30 minutes at a time. But after that, it is rated at 6,500 watts, which is plenty to run this building. That will also run the heat pump just fine, as well as the hot water tank, but that doesn't need to come on very often. The beeping is because the fire alarm system has gone into trouble and now it just cleared. I have a detector that keeps going into invalid reply occasionally. You can see, looking at the transfer switch, this contactor is pulled in, which is our generator feed, and our utility power feed is not pulled in. So that is exactly how this system would work in a power outage. And you can see it worked fine. The generator actually started oddly quick, which is strange because it wasn't at temperature, but well, I don't know what to tell you there. This generator only runs this garage building. It does not run my house. The house is too large of a load. I have a whole video explaining that, but it runs this building as well as all the backyard lighting. So the light on that tower, the gazebo, and this light pole, anything supplied off the generator. I've now given the generator a little bit of time to run and warm up, so we're now going to switch back over to utility power and replicate what happens when the power comes back on after a power outage. So the load has now been transferred off the generator, and in about another minute later, the generator will shut down. So guys, that is the generator and how that worked. Now, this setup, I will admit, it is not perfect. It definitely has its flaws. I have had times where it has failed to start properly, or it has failed, or it has started, but it doesn't like to actually register that it's running. I've had problems like actually today where it seems to trip the overload on the generator once utility power goes back, which actually has no effect on restoring power. It just means the generator doesn't get to run for a cool down period of time while putting out load, while putting out power. It still is running, so it's a very minor thing, but it definitely is something I've noticed that probably 1 out of every 10 times happens. I don't know why. So like I've said, it's not without its flaws. I am not trying to say it isn't. It's just the best I can do with what my budget is as a 17-year-old and what I can come up with. It's the best I've been able to make it work. But people do leave suggestions. People definitely hate on the setup, which is what it is. Whatever, it isn't perfect, but I am always happy for any constructive criticism, I guess, any ideas people have. So anyways, that's going to be it for this one. If you do have any comments or questions, feel free to leave those down in the comment section. And if you do enjoy my videos, make sure to give them a like and subscribe. And also, if you are interested, I do have an Instagram account at Pickle700 for bonus content, stuff posted earlier than you'd see it on the YouTube channel, that sort of thing. Alrighty guys, thanks for watching.